friends, welcome to Organic Chemistry Tutorials. Today I will teach you Friedel Craft's acylation reaction. So let's get started. In this reaction, this hydrogen atom which is attached to this benzene ring is substituted with this acyl group, and this reaction takes place in the presence of acyl chloride and the Lewis acid catalyst which is known as AlCl3. Now let us discuss the mechanism of this reaction. In step 1, the electrophile is generated. In this step, here you can see the acyl chloride which is denoted as RCOCl. Here is a carbon chlorine bond in which chlorine atom bears these lone pair of electrons. These lone pair of electrons can be donated in the vacant orbitals of this aluminium atom of AlCl3 catalyst. So we will get this species in which chlorine atom gets positive charge and this aluminium atom gets negative charge. Now this carbon chlorine bond is broken due to the higher electron negativity of this chlorine atom, and we get AlCl4 minus and RCO plus, which is known as acylium ion. Now this acylium ion is resonance stabilized. Here you can see these lone pair of electrons can be shared with this carbon atom. So these are the two resonating structures of this acylium ion. In these two resonating structures, this resonating structure will act as an electrophile for this reaction. Now let us move on the step 2, which is the attack of electrophile on aromatic ring. Here you can see this is a benzene ring. Here sigma bonds and pi bonds are present. 3 pi bonds are present in this benzene ring which are loosely held. So these pi electrons can be easily broken. So this benzene ring act as a nucleophile for this reaction, and it can be attacked by this electrophile. So there is a positive charge on this acylium ion. This positively charged carbon of this acylium ion attacks on this carbon atom of the benzene ring, and here this pi bond will break, and this carbon atom will bond with this COR group which is known as acyl group, and this carbon atom gets positive charge. Now this species is resonance stabilized by the delocalization of the pi bond. Now this positive charge is stabilized by the delocalization of this pi bond. Now this positive charge is stabilized by this pi bond. So in this way we get these three resonating structures of this species, and this is the resonance hybrid of all these three structures, and this resonance hybrid is the true structure actually. And this resonance hybrid is known as sigma complex or valent intermediate or arenium ion or benzenium ion or cyclohexadienal cation. Now let's move on the third step, which is the removal of proton. Now you can see this AlCl4 minus which is generated in step 1. Now the chlorine aluminium bond will break due to the higher electron negativity of this chlorine atom, and we get AlCl3 and Cl minus. Now this Cl minus will act as a base, and it will abstract this proton, and we will get the double bond in this benzene ring again, and we get this acylated product. So in this way the hydrogen atom of benzene ring will be substituted by this acyl group, and here we can say the whole mechanism which is followed in this reaction is electrophilic aromatic substitution, because here this electrophile is substituted on this aromatic ring. So in this way this acylated product is obtained. Thanks for watching this video. Please provide your feedback in the comments, and you can tell me if you did not understand something, and I will tell you to give the answer. You can tell me what concepts you specifically want to learn, and that will help me in deciding for the future videos. And also subscribe my channel to keep getting the update about the latest videos, and share it among your friends. Thank you so much.